Today, we're diving into one of the most mind-bending concepts in all of physics. We're talking about a state of matter that, for the longest time, scientists were pretty sure was completely impossible.
So, let's just start with a huge question. It sounds like something straight out of science fiction, right? I mean, we think of the laws of physics as these fundamental, absolute rules of the universe, but what if we found something that seems to just ignore one of them?
And that something is called a time crystal. Yeah, the name alone sounds incredible, but trust me, the reality is even stranger. And this isn't just some wild theory on a blackboard, it's a real, newly discovered phase of matter.
Okay, so to really wrap our heads around what a time crystal is, we first need to make sure we're on the same page about what a normal crystal is. Let's just quickly lay that groundwork.
So, a conventional crystal is all about structure and repetition. But here's the key. It's about repetition in space. It's this perfectly ordered grid of atoms that just extends out in all three dimensions.
And you see these things everywhere. That perfect super strong lattice that makes up a diamond, or the beautiful six-sided pattern of a snowflake. Even the tiny little cubes you see in a salt shaker. Those are all space crystals. Their patterns repeat across space.
So there are two really crucial things to remember here. Number one, the pattern repeats in space. And number two, these crystals are in what's called their ground state. It's their lowest possible energy level. They're stable, they're at rest, they're settled.
Okay, so you've got that picture in your head? A stable crystal repeating in space? Good. Now get ready for a pretty major conceptual leap, because this is where things get wonderfully weird. We're about to add a whole new dimension to this idea. This is the exact question that Nobel Prize-winning physicist Frank Wilczek asked back in 2012. He wondered, what if you could have a system where its structure repeated on a regular schedule over and over and over again, like a ticking clock, but at the quantum level?
All right, we've set the stage. Let's pull back the curtain and actually look at what a time crystal is and how it works.
So, here's the breakdown. Imagine you've got a bunch of quantum particles. You hit them with an energy pulse. Let's say you zap them once every second. Now, logically, you'd expect them to react every second, but they don't. Instead, the whole group sort of collectively agrees to flip only every 2 seconds. They find their own new rhythm. And here's the crazy part. Thanks to a weird quantum effect called many-body localization, they get locked into this pattern and just keep ticking at that new rhythm forever without any more energy needing to go in. This is honestly the best way to think about it. Once you give it that initial push, it just keeps on ticking at its own unique frequency. It really is a form of perpetual motion, but it's not making energy out of thin air. It's just keeping perfect time forever. And looking at them side by side like this, well, that's the real aha moment. A space crystal is static. It repeats in space. A time crystal is dynamic. It repeats in time. A space crystal's natural state is just sitting there, at rest. But a time crystal is never at rest. Its natural state is this perpetual taking motion, which it somehow maintains without using up any energy.
Okay, so let's circle back to that big hook from the beginning. We asked if a law of physics was being broken. And the answer is, well, yeah, kind of. But it's a very specific and pretty subtle one. This isn't about getting free energy.
The law that gets broken is called time translation symmetry. Now that sounds complicated, but the idea is actually pretty simple. It just means that the rules of physics are the same now as they were yesterday and as they will be tomorrow. You could think of time as a perfectly smooth, featureless road. Every point is just like the last. That's the symmetry. A time crystal basically puts repeating speed bumps on that smooth road of time. It doesn't look the same from one moment to the next because it has a preferred rhythm. Its state at second 1 is different from its state at second 2, and that pattern repeats forever. It creates a stable structure in time, breaking that beautiful symmetry that says all moments should be the same. So you might be thinking, okay, that's a cool physicist party trick, but what's the big deal? Well, discovering a brand new phase of matter is always a huge deal, and this one opens the door to some absolutely incredible new possibilities.
So why should you care? Because the one thing time crystals are is incredibly stable. Their ticking is just locked in. This could be a game changer for building quantum computers, which are notoriously fragile. It could also lead to creating clocks and sensors with a level of precision we can barely even imagine right now.
At the end of the day, this discovery just fundamentally changes our whole understanding of what matter can be and what it can do. We were all taught that perpetual motion at this level was impossible, but it turns out we just weren't thinking weirdly enough. This has opened a brand new chapter in physics.
And that really leaves us with one last huge question to think about. We've just learned that time itself can host a crystal-like structure, a hidden pattern. So it really makes you wonder, doesn't it? What other fundamental parts of our reality have these incredible hidden structures that we haven't even begun to discover yet? The universe just got a little stranger and a whole lot more exciting.